Welcome back, Cotter. Here we are again to the point and beyond, getting into Ghpython scripting. I'm going to do something here that I think is pretty critical for beginners. And the reason I've kind of brought everything back down to its basis for this entire series on To The Point is to get people who've never done this before, maybe never even did Rhino, maybe even hadn't even played with Grasshopper too much, but actually were interested in this power of scripting within this. So what we're going to do here is we're basically going to shake out the post node process of all this jiggly. We're going to tuck that into a nice little script of this node. So even though I've moved it up a little bit, even though the move doesn't really matter, having to make a sphere after a series of points, after even going to the point of writing it into your script, might be nice to just tuck that sphere into here, and this factor you can see as the radius going directly into your node as opposed to having to go over to a post node sphere. So that's what we're going to cover, and I'm going to write it from scratch. I may leave this one kicking around just to show you, but how you'd set this up and how you build this script is pretty simple. And we'll just put this on disable and start with a beautiful math tab. Jumping into our maths, vectors, got to jump over a little bit. Oh, can I get there? There we go. Maths, and start with our little Ghpython node. We'll make a little script here. And we'll make it similar to what's going on here. So open up our editor, and we'll keep the other one running, just so you'll see why I did what I did. So it's going to make it easier for me to just cut and paste what I did. So let's bring this down and say, what will we start with on a script like this? And we're going to do something pretty dead simple that we've done a few times, but we're going to start introducing geometries into the Ghpython node as opposed to doing that post node, which is something I get in the habit of doing way too often. Let's just control scroll that down in size and have a look at what we have going on here. So you're going to use your Rhino script syntax as RS. You're not going to have to go into any Rhino geometries. We're going to initially make a points list because we probably will end up using those points to do something with the sphere, considering they could be the center. And you generate a point of Rhino script by adding point, and you will need a point, and we're just going to start at 0, 0, 0. You don't have to do that, but for this sake, since we're not focusing on this, we'll just start with something basic like that, and we'll append that points list to get that list full of those points. That's a nice beginning. You've done it several times. I'm going to throw a vector in there, except this vector, what shall we put the vector at? I don't even know. Let's just put the vector moving at, even though it jumped up there, let's just make that vector equal to a 1, 1, 1 vector. So we don't have to put anything in here. We don't have to put our x, y, z in there to inform it. All we're really going to need here for this script, and we'll get there, is I can anticipate a count, integer, and a factor. I think that's the other one that I was using there. A factor as a float. And that should be all we need to input if we can hard code in our vector. So it's going to make that a little shorter. Now you do a for I in range, going through all of the count, which happens to be set at, what do we set this one at? 4, and let's just set it the same so they do-si-do the same way. A 4 count and a factor of 4.52. That seems to work in that last one. And that is not a factor. It is a factor, but actually we're going to use it as our radius. So I should get that right. We will have some outputs as we'll get into here as we go. But there's the I in range, tange, which is interesting, range, count. Then create a new point and set that new point to a Rhino script function copy. And this is where it gets interesting. Copy object. And I like copy object because you could copy the first object in the list. That'd be fine. Or you can use what lists have power to do, grab the points objects. You could just copy the first object and move it with 0. And I'm pretty sure that's what would happen. You don't want to have another number because it'll move outside of that range. But the other thing to do is set it to -1, which goes to the item last in the list. And if there's only one item being appended to it, then obviously it's going to pick that item. So hopefully that makes, and you're going to have to move it by a vector. And our vector has been constructed 1, 1, 1. So that's how far it's going to move. And I think we're going to jazz this up a bit because we had it hard-coded at 10, so it was visual. So we'll just had it in here at 10, x, y, z. So let's just leave it at 10 so it matches the data on the one before it. At that point, you want to append the points list again, and you will be appending it with the new points. And we're going to do the exact same thing for spheres. I'm going to show you in a minute. And I always like to print. And what I'm going to do here is in Rhino script syntax, it doesn't produce geometries. It produces unique identifiers, or GUIDs. So we're going to actually print those to get you into a debugging process of all the iterations of what they were. And being able to run that, we should have, I have a problem without rs is a token. What did I do wrong? Points. Append rs. I have a new j here, which shouldn't be happening. Let me try it again. What is the problem? It says exception token rs, so probably means I have something dosy-doing around here in the wrong spot. Print is. Not sure why I am having a problem. Maybe I'll just keep plugging through and see if I have an issue with it later. This script is running here. rs token. That's not doing anything. The count isn't doing anything yet. 4 count. But I do have something wrong with my script. Just debugging, going backwards. So I like to read backwards when I have a trouble with something. Points append. Well, we can always get a little more data here. It says line 4, your points 0, 0, 0. Add point. Token rs is not correct. Well, there it is. I didn't have the equal sign. And of course, I'll look back on this video and be like, how did I miss that? So that should be fine. It should get us running, get us producing. And this is why it's so important to debug. And I always suggest get a panel up to that out to make sure your data is running, because it will show you the same errors down here, but over here. So we have a bunch of GUIDs that are being produced. And there should be 4 of them if I'm set to 4, but actually there's 5 because I'm set to 5. And it starts counting at 0. So everything's going according to plan. And then I may want to leave the scope of that function and have points underscore out set equal to points. And in doing so, points, we're going to want to change this A over here to points out. Hopefully this is becoming pretty familiar, this process, and you get into, repetition. It's like learning anything, language or anything else. So let's just grab those points as a geometry. We should have a double curve coming from here. Let's test it. And yeah, there we go, double line, because we're dealing with a list, and there they are. And if we took a look, you can anticipate that we have a bunch of points. I'm not even going to bother. They look like they're all in different spots. They're different global identifiers. We're fine with that. Now, instead of going in here and being dependent on grabbing this data here and copying that and saying, okay, let's go back to my old school of there's my base geometry. I don't even have to move it. I could just take that geometry and just put it into here. It's a small thing, but it kind of shows your lack of being able to do it, that you can do it that way. And then you're dependent on a radius that then you have to plug back in, this radius over here. So why is it even feeding into the node if you're going to feed it into there? So let's try and prevent that from happening and go back into the script and write exactly the same way, but what's needed, because in the end, let's go down to the end. And I like to work backwards when I do geometries. If I set up spheres, a list of spheres, just like points would be out, I want to set that to spheres. But I'm like, well, what do I have to produce spheres? Well, spheres will be created probably as a list of things. So I will create spheres off the bat. And normally I would put it up here, but I'm going to separate this just because. And I think what I'm going to do here is just print a blank line, just in case we want to see where that script's different. So I'm just going to tuck that in there just for fun as we take it to an output. But spheres is going to be created as an empty list to start, just like the points was created as an empty list to start. And then I'm going to create a sphere, which is not those spheres, but I'm going to create a variable called sphere that is going to be the Rhino script add sphere function. And that's going to tell me what it needs. And it needs a point. And I can use the points, the point form that I had above as 0, 0, 0 to start. So that makes sense. I can just go back to my point tool that I had going on. And I need a radius. Well, since I don't want to hard code it in, I brought it in as a float over here. So that's running and creating a sphere. Now, back to the list of spheres. That should start making sense. You're going to append that, just like you did the points empty list with point. You're going to append this one with what is coming out as sphere. boy, this likes to jump around. Hang on a second. I don't know what happened there. What the heck? There we go. I wanted to append that with sphere. In doing so, I was then going to print my blank line, but I'm not going to bother, and I was going to print my sphere and find out if there was a GUID or not on that. And I guess I could do that, and that would bring up more data you'd see over here in this column. So I think I will. I think at that point I will just print my sphere to make sure that it exists. Not spheres, but just sphere. And then we're going to run through the same iteration for I in range, the count, once again, because we can use that. And when you're done this, you can take everything off up here, so long as it's not being used in this function down here. So you have to remain the point, but we could be able to run and take off all this, I think, with commenting it out. But let's leave it on just to see how it runs. We're going to create that new sphere, just like we created a new point. And we're going to set that to the RhinoScript tool of copying an object. And we want to grab the last object in the spheres list. So that's easy enough. And I told you we can do that by using -1. Use 0 to get the first one, -1 to get the last one. We're going to move it by the vector that we have hard-coded in. We then, and I'm going to stretch this out a little bit because we don't want to get confused about our indentation, which is so important in the Ghpython as opposed to C#, which you could do with curly brackets. And the spheres list will be appended by those new spheres. And we'll just call them, just a little tricky getting all these new sphere. And at that point, I might print all of the spheres, which is what I did in the last one, at all the indices of values of what they were. So there'll be a little jumping around. It could be a little confusing to look at in the output. And in the end, we're right back to where we needed to be to produce the spheres out. So let's test it. We've got a problem with a GUID that's not scriptable in line 26. Print sphere. What did I do wrong? 26. That means there's a problem up here above. Spheres, new sphere, append. Very strange. GUID is not scriptable. Well, it's running as the exact same script as above. What I may want to do is just, I'm not even sure what I'm doing. It looks like it's running. Looks like I'm getting data. But I have an exception on line 26, which probably, like I said, is not this one. That's the actual problem. Of course it's not scriptable. I have my sphere being scripted and not my spheres. And that should run it. So what we have in this output, if we look at it, is what has that function asked us? Well, it said initially, let's print out all of this first range. Now what I'm going to do here, because I don't really need this, is I'm going to comment it out with a multi-line comment. And it's gone. I have my print line here, which I don't need to leave a space because I'm not printing those new things to distinguish. And we go right back, and now we're just running the bottom half. The only thing that's dependent, not that we even need the points out, the only thing we might want to do here is go in and hit exactly what we're trying to bring out, which is the spheres out. And with that, any luck, the points were running here, but they're not running anymore. Well, they're not running as a list anymore. Points out isn't actually doing anything. But the spheres out is definitely going to produce a geometry. So let's jump into here, grab the geometry of what we need, because we know it'll be a sphere when it comes out, and we should have a list running to that. And that said, we've run this one pretty good, and there are our points. And outside of having to take that list of points, if I wanted to run that first part, which is not running this data now, instead of having to go in and make my sphere after the fact, I can control the radii of that sphere through the function itself. And maybe that slows this down a little bit, but it probably saves time in the process of running everything again to turn these points into spheres. So hopefully that starts to get you doing exactly what I wanted to do this demo, is to get you scripting and get you scripting more. So hopefully that makes some sense. It's a breakdown that I've learned text after text, but nobody sit there and show me. Like nobody really, I'm not in classes, I'm teaching classes. So it's like, what is the basis of this? And I think what I'll do in the end for this function is just delete that, delete this. We don't need the points. We don't need these points appended. We actually can go right back into just having that vector created. The spheres can be a list that's created. it might be good practice to take our lists initially and move all of our blank lists at the top. So take that out, put that right here. That might be better form, creating that point, the vectors, the spheres. Let's run the test. It still runs, and we don't need this point anymore on here. The points out is not in use anymore. So we've got a count and a radius that produces spheres. And maybe if we think back to what was going on in Grasshopper under surfaces as we create a sphere, it needs a base and a radius, and you've basically made yourself the node scripted to what actually was going on over here. And that really is the game. The better you get, the more you can follow this. And what happened, radius? Oh, base is not a count. It doesn't care for that. It's not moving objects. If you think about this node, it really is just defaulting to a base with one sphere on it. So you're getting a single item, whereas then you have to do a bunch of things to move that in an array into another position and do the translations, whereas really you've scripted in here a very fast use. So all of a sudden this becomes a pretty useful tool. And we will call this, what should we call it? Let's call it to the point, move objects. And we don't know what you want to move, but we would have to say, honestly, for this one, move spheres, because that's what's in there. And you'd have to retype other things to get it away from that. But moving spheres is also a sense of what it really means by moving is copying it and putting it in another spot. So I'll grab that, copy, go up here to File, create a user object, go down here, grab my favorite, my favorite icon, pop it into here to the red because it's in that series. It's a test. It should pop up here somewhere. It's starting to get a little jumbled in here. Oh, what are the odds? I love that it's just a guessing game with me. Move spheres. It's not what the other one's doing. I really don't need this to even compare it. You can just grab that data into here. Move that into here. What's nice about here is you can go into any one of these nodes, and I believe there's an option to get rid of your out input, which you don't even need it. But since I am using it still and I'm not compiling these and getting rid of that, I can leave it in for a while. And I am able to do my count and change my radius and have a pretty good sphere tool to whatever I want to do. Of course, it's moving it in a I don't have it as jazzed up as this one that I can set in a vector to do some things, but you start to get this. It's starting to make sense to you, and why you would do it, and why you would customize your own things without plugins, and how you can send your own user objects onto other people. So once again, get scripting, WICKERSON Studios, have fun with it, write your scripts, change them up, learn from the basics and make things more intermediate and advanced for yourself as you go. That's it. Thanks for watching.